Hi there. Hope you can hear me. Let me share my screen and start with actual slides. So today I want to speak about web workers and in general parallelization in JavaScript. Before we start, a few more words about me. I'm Vitalii, I'm lead software engineer. I'm working for IBAN Poland in Wrocław. I'm organizing Angular Wrocław meetups. I'm speaking at tech conferences online, previously offline. And you can find me on Twitter or visit my blog. So what is the problem with JavaScript? Why we need this thing called web workers? All of you probably know that JavaScript is stated as single-threaded language. Yeah, we have only one execution call stack, and we can do much more with it. That was true for a long time, but actually now there are a bunch of ways how you can parallelize tasks for your applications using web workers, service workers, worklets, and WebAssembly. So this statement that JavaScript is just single-thread language is not true anymore. So what problems we can solve with web workers? Here you can see it's simple UI. It renders some items and runs sorting of those items. If we will run this task in main thread until it will be finished, our interface won't be responsive to the user. User can't click any buttons, can't scroll the page, can't do anything. But if we will run the same task but in worker in parallel with our main thread, user will have ability to work with our application. And those unresponsive interfaces making our users disappointing. They trying to click few times on some buttons, and when the long-running task will end, actually it is possible to dispatch multiple events that was scheduled before. For example, it is possible to have multiple backend calls and things like that. So it's bad for user experience and performance of your front end and even in some cases backend applications. And the main statement here is that users should be able to use the applications even if you're running some hard, heavy tasks on the main thread. So here's the same example. We're running the same task on a worker thread, and user can click some actions, can update UI. But the thing is that the time of execution of that same task on worker might take slightly more time. In the previous example, it takes like 600 milliseconds, and now it's about 10. I will describe what overhead do we have, and why we have longer running time, significantly, almost 2 times longer in worker thread. But it's a small trade-off that makes our applications more responsive. So before we can actually use workers, there are a few security limitations with them. So the main thing is that workers should be contained in a separate file. There are some workarounds. You can create this kind of file on fly using blobs and decoding, but it doesn't change the statement itself that we need a separate file to our code. The reason for that is that worker code is executed in separate JavaScript context. And in that separate JavaScript context, there is no access to things like DOM or global functions. But still, you will be able to import some modules. You will be able to make HTTP calls. And the only one way to communicate between those threads is to use messages. I will just show them examples later, but you just have a bidirectional messaging channel between your main thread and your worker thread. First of all, I want to make a disclaimer that you shouldn't optimize your application code before you actually got problems with it. Usually these over-optimizations lead to hard to maintain code, and if you do, for example, developing some simple application that doesn't have really heavy tasks, there is no need to use workers with it. And on the other hand, your coworkers will hate you if you will overcomplicate the code base without any reasons. So how we can use web workers? Let's deep dive into this API. It's really simple. You just need to create an instance of worker, passing it the path to your worker code. As easy as it. It loads the worker module and gives you an instance. If you will speak about browser support, it's actually really great. It's even supported by IE 10 and 11, so you can even use it in legacy applications. I don't think that there are that much actively developed applications with support of IE 9, but in general, it's available everywhere except Alt IE and Opera Mini, which is a very specific browser for very specific needs and market. So I wouldn't care about it that much. So how we can communicate between our worker and main thread? It's obvious that to execute some task, we need probably to pass some data to worker and get back the results. So in the main thread, you have a method postMessage on your worker instance, which accepts data that you want to pass. And on worker thread, you have a global function available for posting messages. To receive messages on main thread, you just add in an event listener on messages, and you can get data in this event. Same thing is going with worker thread. You have a global function, add event listener, and you are listening for messages from your main thread. So you set up these communication channels. Worker waited for data to process, and your main thread waiting for data, resulted data. And the downside of such message channel is that it can utilize a really big amount of memory. Because our code, worker and UI code executed in separate JavaScript context, we can't pass the reference to data between them. Browser actually takes data, makes a shallow copy, and passes it to worker. Then, with resulted data, it does the same in opposite way. So it takes the result data, makes a copy, and passes it back. How we can avoid such situations? There are a bunch of ways to do that, and first of it is using buffers for data transfer, or as it's called in API description itself, transferables. So we can use array buffers, signed integer buffers of different sizes, things like that. The only thing we need to remember that if we're using such data structures, we need to pass them as an argument to post message first and as a second argument in a list of transferables. So every object that is transferable and shouldn't be copied should be passed in these transferable arrays. Then you can easily receive in a worker thread and process. Same goes with the resulting data. You can use buffers. So in this case, you save a lot of memory. For example, if your data set is pretty big, like few megabytes, if you will copy it over and over, you will utilize a lot of memory and save it with buffers. There is another way. It's called shared array buffers. It's actually an object that could be accessed by reference from both threads, main and worker, but because of CPU's security vulnerabilities, it wasn't available for a long time. Those vulnerabilities related to meltdown, and it was in Intel processors. After they was introduced, browser vendors actually disabled shared array buffers, put them behind the flag, but now they resolve the issues with access of this data by third parties. And they started to release it, so it's available on Chromium browsers, in Firefox, and in Safari behind the flag. So to manipulate with a lot of data, we can actually create a pool of workers, multiple workers that will run your code in parallel. How to do this? It's just easy. We can decide the size of our pool and create an instance for each of it. And probably not a lot of developers know, but there is a property called hardware concurrency on Navigator object. It gives us a hint about logical cores of your machine. So, for example, if you have a 2-core but poor threads CPU, you can run for workers in theory, of course. And Navigator hardware concurrency gives you a hint how many logical cores do you have available. You can't heavily use this property because it's just a hint. It might be not exposed by the system, the real number of hardware, because it's kind of data that won't be exposed to everyone. But actually you can use it. And the funny thing, the story, how I get knew about this property, I just took a look at code of Bitcoin miner CoinHive, and they use this property to set up parallel workers to mine the coins. Also, I would suggest to leave one thread free for your main UI thread. If you can create actually more workers in parallel than you have actual cores to process them, but they won't run all of them. Only workers that have free core to process them will be running. Others will just wait for hardware to be free. And yeah, as I wanted to say is that thread is not equal to CPU core. It's actually common for Intel CPUs that might have 2, 4 cores, but actual threads available might be 4 and 8 and so on and so forth. So another type of worker is a shared worker. Shared worker is very special because it's available worker instance that could be used by few tabs of the same origin. Let's say you have a user have an application open in one tab and same application open in another browser tab. So both of them will use the same shared worker. So the data will persist between tabs. The only difference in API is how you communicate with shared workers. Instead of directly posting messages, you posting messages on ports. Port is actually a link to pool of open instances of your application, so you can choose between them or send data to all of them. Same goes for workers thread. You just listening to connections to your shared worker, then listening to messages on this particular port, and you need to actually start this port, so it will be available to receive and send data. That's a really slight difference, but to be honest, I haven't used shared worker in my production applications yet, because it's kind of very specific API and use case for it. There are a bunch of helpful libraries that help you to work with workers. And one of that I want to mention today is called Comlink. It's created by Google experiments, and it really simplifies the worker communication code. So basically, it wraps your worker in a proxied object. So you will interact with it like with any normal object in your application, calling methods, properties, and things like that. But all of these actions will be asynchronous, because workers uses messages and events to share the data. You need to actually await for this data. So as you can see, we will create the worker instance, but wrap it inside Comlink. Then, inside our worker thread, we just create an object or class, instance of a class with some properties and methods, and we actually expose this object as a public API of our worker. So everything that you expose will be available in main thread to use directly. So instead of listening to messages, deciding what kind of task should worker to do. Are we live?
Yeah, you're live.
Okay. So I stopped on data manipulation case study. So the requirement was to handle a big amount of objects on client side, like hundreds of thousands of items. And I need to sort those objects by different properties on a client side. Don't ask why we don't do this on backend. It was just such a requirement. Before we'll deep dive in this task, let's remember what is time complexity of an algorithm. So algorithm are estimated asymptomatically by functions. How the function will behave when you have bigger data sets passed to it. So the best results is log n, okay-ish results is n log n and n square and so on. It will be a pretty non-optimal algorithm. The most performant sorting algorithm are n log n of time complexity. But if there are particular algorithms that could be used for parallel sorting, one of them is called external sort, which is just parallelized version of merge sort. If you don't know, actually browsers use different sorting algorithms behind the scenes for your array sort method. Most of them using quicksort and merge sort, but they might switch algorithms depending on the size of an array. So how it looked in code. In main thread, I created a pool of workers using navigator hardware concurrency. I left one of them free, and depending on how much workers available I have, I divide my initial data set into chunks. Then I created an instance of worker for each of them and set up messaging, communication, and passing the chunk to process for each of them. Once one of workers free, I can pass chunk if any available to it. How it looks in main thread, how I just gathered this chunk. So I created different types of tasks. One called chunk, where I just pushing this data slice to worker to sort. Then I need to get all these chunks together. So I have another task called chunk sort and chunk merge. So after all these chunks are sorted, I need to merge them together in one sorted data set. What could be improved in this solution? First of all, the memory usage should be improved using array buffers instead of passing the data copies between the threads. And as an optimization of algorithm used itself, it is possible to use topological sort for things like tasks. Topological sort is a sorting that could, for example, solve the task for sorting tasks that depend on each other. So you have a graph of tasks. One task requires another to be finished first, and topological sort will help you to achieve the proper order of those tasks. Second case study. In our application, we have a comment model, but the thing is that user is not seeing these comments right when he opens the details page, but only afterwards. They are placed on separate tab. So it's actually a good candidate of job that should be moved to a worker. Yeah. So what I did, again, I created a pool of workers for each of the comments available. I created an instance, set up listening, and until I have some comments to process, I pass in this comment to process to workers thread. Then I receive in the result and render it to the user. So user is still able to use the details page and see the parsed comments afterwards. How it looks like in a workers thread. For actually parsing and markdown, I need a third-party dependency parser itself. So I need to import some scripts. And it's possible on workers thread to use import scripts method on self, which is a reference to worker itself. So I created an instance of parser and process data with this parser and post message back. What could be improved in this solution? Again, actually the code itself could be way more simpler if will be used with a Comlink. So I don't need to create any different task types or things like that. I can just wrap my public worker API into an object and expose it as a method. And another thing, it's actually room for improvements, memory utilization again, using shared array buffers or array buffers. And the last one, it's tuner autocorrelation. Autocorrelation is an algorithm that helps you to get the most significant value from a list of values. So I need to run this analysis in background to be able to immediately update UI, because it's the processing and updating UI is actually like few milliseconds. So I need to immediately show the user to the user result. And I need to debounce analyzing audio data requests. I'm getting an array of numbers that represent frequencies of some sounds that produced by instrument or other thing, and I need to run this autocorrelation algorithm on it. The data set is pretty big, yeah. It's in my case it was 128 items in each cycle, but it depends on actual sound card possibility, so it could be bigger or smaller. And I want to show actual application. So here you can see it's an audio application, and I need to probably mute it. Sorry. Okay, so I have this tuner. And now, while I'm speaking, it tries to recognize frequency of a note I'm speaking, and immediately show result to the user, as you see. And it runs a lot of calculations each 10 milliseconds. And if I will use this algorithm in main thread, I won't be able to actually update the UI in a frequent way. So it wouldn't make any sense to do this tuner if it's not responsive. What could be improved in this solution? I want to go further with it and implement the algorithm in WebAssembly module. The thing is, as we can import any modules in our worker, we can actually initialize our WebAssembly code inside worker. Actual WASM initialization and parsing, it also takes CPU time. So it makes sense to do this job on a worker thread. Then run the actual algorithm in a WASM thread and pass it back to the main thread. And it, as WebAssembly is really good technology for heavy mathematical computations, autocorrelation algorithm is a good candidate for this API. That's everything I have for today. Try to use web workers in your applications and make them more responsible and reliable. You can find slides on Speaker Deck. I will share them the link to them on Twitter as well. And yeah, you can follow me or visit my blog. And thank you very much for attending. Have a good Friday.